Hi, my name is Patrick McCarthy, a maths tutor. I'm going to help you understand quadratic sequences. Okay, so sequences are just exactly that, a sequence of numbers, and a very basic sequence is an arithmetic sequence where the difference between terms is always constant, i.e. 3, 5, 7, 9, 11, 13. Here you can see the difference between the two numbers every time is 2. 3 to 5 is the difference of 2. 7 to 5 is the difference of 2. 9 to 7 difference, etc, etc, etc. Okay, now what we're looking at today is quadratic sequences where this difference, 2, 2, 2, isn't constant. Okay, so the difference actually goes up. That's what a quadratic sequence is. So an example might be something like this: 2, 5, 10, 17, 26, 37, okay? So what happens here is, you can see the difference between two numbers here is 3. Now it's 4. Sorry, now 2, 3, 5, 7, 9, and 11. So actually the difference between the two numbers is actually going up. But what we do is write down, in between the two numbers, the difference. So here we have 3, here we have 5, 7, 9, 11. Now in a quadratic sequence, the next step down, you can see the difference between these differences is now 2. 2, 2, 2, 2 is our old sequence. So this is what a quadratic sequence is, when the second difference is constant. If it was the third, it would be a cubic sequence, etc. But this is a quadratic sequence. Now what we do is somehow we have to relate this number here, the 2, we know it's quadratic, i.e. has an x squared in it, something squared in it, and how to relate this 2 here into the sequence. So what we want to do is say, right, the first term of my sequence is 2, the second term of my sequence is 5, the third term is 10, the fourth term is 17, the fifth term is 26, the sixth term is 37. So somehow I need to use this 2 here to relate this number to this number, this number to this number, an overall formula. What we do is we take this number 2, we half it, okay? You half it to get obviously 1. So this, I know if I take this number n equals, let's say u equals, if I say, right, I want to take my n number and find out what my u number is, using what I just said, half of 2. So what we do is we half 2 and put it in front of n squared. Okay? Now if I write n squared here, I get 1, 4, 9, 16, 25, 36. So I'll rewrite that there. So what I need to do now is relate this n squared number to my sequence. So I know that I've taken my 2, I've halved it and put it in front of my n squared. So I actually have a secret 1 there. Okay, so I've taken my 2, halved it and put it in front of n squared to find that it's, so now I know it's a quadratic sequence, I use n squared. N squared goes 1, 4, 9, 16, 25, 36. And you can see that all I need to do from n squared each time to get to my u number here is add 1. So my sequence is n squared plus 1. Now what this does, it says give me an n number, so I know that if I take n as 1, 2, 3, 4, 5 or 6 and on to 100, you can give me any n number and I can tell you what the number of my sequence is using this formula. I.e., let's take n is 4. Right, take n is 4, put it in there. N squared is 16, plus 1, 17, and I'm at my goal. So that's what we do, we take the common difference, the second common difference of our sequence, we halve it, put it in front of n squared. Then you write down your n squared here, and then you need to add on a number to get back to your sequence. And that's quadratic sequences.